Coca-Cola claims that each can contains 12 fluid ounces. We want to test this. So we sample 30 cans and find an average of 11.9, so a little bit less. Our sample of 30 Coke cans has a standard deviation of 0.11 fluid ounces. We want to use a significance level of 5% to test the company's claim that the average is 12. So let's give some variable names to things. Let's think about the claim first. The claim is that the average volume of each Coke can is 12. So the claim is equality, meaning that it's going to match our null hypothesis. We're going to choose to center our distribution at 12. The alternative is then that it's not equal to 12. All right. From our sample, we measured an average of 11.9. The standard deviation of our sample was 0.11. And let's remind ourselves what N was. N, we took 30 Coke cans and sampled them. So if we draw the two normal distributions, one for our actual data and one for the t-scores of our data. So our actual data is centered at 12. I centered at the null hypothesis, and our sample is a little bit to the left of that. It's a little bit less than 12 at 11.9. Right? The corresponding picture for t-scores, I center it at 0. And I'm somewhere over here, right? I just don't know where yet. So let's figure out the critical t-scores. So how sure do I want to be? I want to use a 5% significance level. So because I use 5%, but my claim here is about equality, meaning that my alternative is about inequality, it would be important if I was on the left side of this curve or if I was on the right side. So I'm going to take this 5% and I'm going to split it up. I'm going to put 2.5 in that tail and 2.5 in that tail. All right, that leaves me with 95% in the middle. So let's figure out our critical values. What are these two dashed lines? So from our critical value sheet, remember to use t-scores because we're dealing with averages. Your sample size of 30 has 29 degrees of freedom. And from your t-score sheet, you see that these two t-scores are 2.045 and minus 2.045. So if I'm anywhere outside of these values, I'm surprising enough, that would be significant. So let's figure out where 11.9 is. So the t-score of 11.9 is given to us by 11.9 minus the center of 12. And then I divide by the standard deviation, and the standard deviation of averages by the central limit theorem is the standard deviation of our sample divided by the square root of our sample size. If you do this, you will find a t-score of not exactly equal, but roughly equal to minus 4.979. So where is this? Minus 4.979 is further to the left than minus 2.045. So we are well into that critical region. Thus, this is a surprising enough result to warrant the rejection of the claim that your curve should be centered at 12. So we're going to reject the claim, or rather, we're going to reject the null hypothesis that the average is equal to 12. We have significant statistical evidence to suggest that the true average is lower.